Ma'am, chat window accessible അല്ല.
Who was that? Zahan?
Yes, ma'am.
Ah, okay, fine. I'll put that on it. So, okay. I've shared the PPT. Can you let me know whether it is visible or not? Oh, cancel. Thank you. So before I start today's class, your second feedback has been enabled in Spanish. So please do that. Do complete it before the last date. So you might have seen the second series question paper, and you might have understood what is the question format. So as you know, this is a programming subject. You can't expect every program that is out there to be solved in class. So that is why you have your booster classes and all. And if you want any topics to be discussed, you can let me know before the class, or you can ask me during the class. So last time no one had any kind of doubts. So do check the question bank that is available in the Google Classroom. So there many questions are available. You'll be having similar type of questions in your exams. So don't expect this is not plus two. You'll have to solve different problems by yourself. So this is the sixth module. Today we'll start with something called a swing. So swing is related to GUI. So we have started with GUI or the basics of GUI in the last module. So I have taught you that there is something called as delegation event model. I hope you remember the concept and all. So before Swing came into existence, that there was something called as Abstract Window Toolkit, that is AWT. Okay, so Swing, it is a set of class that provides more powerful and flexible components than that was available with AWT. So this is the underlying concept for doing GUI programming in Java. But this is said to be heavyweight, and Swing it is a lightweight system. So we'll see why they are called lightweight and heavyweight. So this is lightweight, and AWT it is heavyweight. So Swing provides the look and feel of modern Java GUI. And it did not exist in the early days of Java because previously we had something called as AWT, and it was there in 2015 syllabus, but in your scheme it is not there. So AWT, it defines a set of controls, windows, and dialog boxes that support a usable but limited graphical interface. So the reason that AWT had a limited nature is that it translates its various visual components into their corresponding platform specific equivalents. So platform specific equivalence means what? What do you think is platform specific equivalence? Anyone? What is meant by platform? We say that Java is a platform independent language. What is a platform? It is not your railway station platform. It is something else in Java. So what is a platform, or in a computing word, we say platform as something, or it is a other name for something. Yeah. So no, it is an operating system. So AWT rendered the components based on the operating system. So this means that the look and feel of a component is defined by the platform and not by Java. Okay. So in AWT, when we were using AWT based graphics, the say a button, I'm taking just one example. So say I am rendering a button. So the look and feel that a Windows OS gives might be different from a Linux OS. Okay. So AWT components, they use native code resources and they are referred to as heavyweight. So this is why it is called as heavyweight, because in order to render the components in AWT, it needs the resources of the operating system. So Java does not do it. It is based on the underlying operating system. So there were several problems when we were rendering components by using AWT, because based on the different operating system, the components might look or even act differently. So the Java philosophy is that you can write once, run anywhere. But because it depended upon the operating system, it has to be created based on the operating system, right? So that is not the philosophy of Java. You need to have, that is, it should work in the same manner in all operating systems. So the look and feel of each component, it was fixed and it could not be changed. And the use of heavyweight components caused some frustrating restrictions, like a heavyweight component might be always rectangular and it was opaque. Opaque means it is not transparent. So that was some of the restrictions that were there with AWT based components. So the limitations and restrictions present in the AWT required a better approach. So that was Sync. So it was introduced in 1997 and it was included as part of JFC, that is Java Foundation classes. So Swing was initially available with Java 1.1 and it was available as a separate library. But beginning with Java 1.2, Swing and the rest of Java Foundation classes was fully integrated into Java. So Swing, although it eliminates the restrictions that are there with, or limitations that are there with AWT, it does not actually replace AWT. It is based, or it is built on the foundation of the AWT classes itself. And AWT, it is still a crucial part of Java. And Swing, it uses the same event handling mechanism like AWT. So the features that are there with Swing is that it provides you with lightweight components and you have a pluggable look and feel. So Swing components, they are lightweight. So remember that AWT, it is heavyweight and Swing components, they are lightweight. So this means that these components are written in Java and they are not directly related to the platform. And the lightweight components, they are rendered using graphics primitives and they can be transparent and you can have non-rectangular shapes. So these components, they are more efficient and more flexible. And these components do not translate into their native peers. The look and feel of each component, it is determined by the Swing itself. And it is not done by the underlying operating system. So each component will work in a consistent manner across all operating systems. The second feature is that it has a pluggable look and feel. So remember this PLAF, if they ask, it is pluggable look and feel. So each swing component, it is rendered by Java code rather than by the native peers, and the look and feel of the component, it is fully under the control of Swing itself. So it is possible to separate the look and feel of a component from the logic of the component, and that is what exactly Swing does. And it has certain advantages, that is, it would be possible to change the way that a component is rendered without affecting any of its other aspects. So it is possible to plug in a new look and feel for any given component without the component means something like a button or something. So it does not create any side effects in the code that uses that component. And it becomes possible to define entire sets of look and feel that represents different GUI styles. And to use a specific style, you just have to plug it in. And once this is done, all components are automatically rendered using that style. So these are the advantages. That is, it will have a consistent look and feel across all operating systems. It is possible to create a look and feel that acts like a specific platform. Like if you know that an application will be only be running in a Windows environment, you can specify the Windows look and feel. And it is possible to design a custom look and feel if you want to. And the look and feel can be changed dynamically at runtime. And Java SE6 provides look and feel like metal and motif that would be available to all Swing users. The metal look and feel, it is also called as the Java look and feel. So it is platform independent and it is available in all Java execution environments. It is also the default look and feel. So metal is your default look and feel. And Windows environments also have access to Windows and Windows Classic look and feel. So a visual component, it's a composite of these three things. That is the way that the component looks when rendered on the screen, the way that the component would react to the user, the state information associated with the component. So no matter what architecture is used to implement a component, it must explicitly contain these three parts. So the architecture that is consistently used, it is called as model view controller. So we'll see what is a model view controller architecture. So this type of architecture, it is successful because each piece of the design corresponds to an aspect of the component. So you have three things, that is model, the view, the controller. So model, it corresponds to the state information that is associated with the component. So suppose you have a checkbox. So checkbox is this, where you can click and a tick might appear. So in the case of a checkbox, the model contains the field that indicates if the box is checked or unchecked. That is, this is the checked state, right? And this would be the unchecked state. And the view determines how the component is displayed on the screen, including many aspects of the view that are affected by the current state of the model. So how this thing appears on the screen, that is determined by the view. And the controller would determine how the component reacts to the user. For example, when the user clicks a checkbox, the controller reacts by changing the model to reflect the user's choice. That is, the controller is the one which would change the model so that checked or unchecked state would be shown. So this would result the view being updated. So these are the steps. So first is the user, what he sees is the view. So user interacts with the view. Then the view alerts the controller of a particular event. Say suppose you have the user tries to click the checkbox. The view has to alert the controller of that event. The controller would update the model and the model alerts that the view has been changed. That is, if this was the previous state, it has to be shown like this, right? So the view grabs the model data and it has to get updated in this form. So see this model, if it is okay, please message in the chat. So you have something called as a model view controller model. So Ansel is okay. What about others? Solely Ansel is here. Okay, Joel. Okay, Irene. Okay, Lydia. So I need at least 3 more responses. I'll see it. Okay. And Maria. Okay. So only these people are here. Okay, Atulya. So I'll continue. I hope I'm unmute. Okay. So the advantage of separating the component into a model, a view, and controller is that the specific implementation of each can be changed without affecting the other two. So different view implementations can render the same component in different ways without affecting the model or the controller. So even though that MVC architecture and principles behind it are conceptually sound, in Swing it is not the actual thing that is used. So it actually uses a modified version of MVC, and it combines the view and controller into a single logical entity called as UI delegate. So view and controller are treated together in Swing, and it is called as UI delegate. So Swing's approach, it is either called as model delegate architecture or separable model architecture. So Swing, it uses a modified version of that MVC. And although Swing's component architecture, it is based on MVC, it does not use a classical implementation of it. So Swing's pluggable look and feel, it is made by using this model delegate architecture, and view is the look and controller is the feel. And they are separated from the model, and look and feel can be changed without affecting how the component is used within a program. So it is also possible to customize the model without affecting the way that the component appears on the screen or responds to user input. So in order to support the model delegate architecture, the Swing components contain two objects. The first would represent the model and the second represents the UI delegate. So the models, they are represented by interfaces, like the model for a button, it is defined by the button model interface. And UI delegates, they are classes and they inherit something called as component UI. So the UI delegate for a button, it is button UI because the component here is button. And normally the programs will not directly interact with UI delegate. So this is how the Swing works. You have the model, which is a separate thing, and view and controller, they are made together and it is called as UI delegate. So this is the architecture that is followed by Swing. It's a modified version of the MVC. So if it is okay, please message in the chat. So you can change the look and feel without affecting. Okay, answer. So in the previous case, you have three things separate, right? Model is different, view was different, the controller was different. But here the advantage is that you have something called as model delegate architecture. So the view, that is the look, how you see it, and the controller, they are separate from the model. So you can change the look and feel without affecting how that component. So component is nothing but your button. So you don't have to change the code related to the button, but you can change the appearance based on how you program it. So you have something called as the model and UI delegate. UI delegate is nothing but the view and the controller together. So the model, they are represented by using interfaces. So if you want to have a button, that is defined by using the button model interface. And UI delegates, they are classes, and it is inherited from a class called as component UI. So if you want to use UI delegate for a button, you will be using button UI. So the programs, in our programs, will not be directly interacting with button UI. If you want to create the button in your program, you don't have to go and directly use button UI. So we'll see some programs related to that, how you will be adding buttons in your programs and all. So this is how Swing uses it. So the model, that is the actual logic, it is separated from the view, that is the look, and the how that model is getting updated, that is the controller. They are together combined, and it is called as UI delegate. So the purpose of everything is still the same, but this is how Swing uses it. Is it okay, Ansel? Okay. So Swing GUI, it has two things, the components and the containers. Because but still containers are, they are also components. So you'll have a container, within that you'll be adding various components. So say one example for a component would be your button, and your container would be a frame, JFrame. So a component, it is an independent visual control like a button or a slider. And container holds a group of components. Like you might have a button here. This is my button. Say it is submit. I might have a text area here. So that is another component. And this is my frame, which contains all those components. So container, it is actually a special type of component that is designed to hold other components. So for a component to be displayed, it must be held within a container. So if you want to display a button, it has to be added into a frame or any of the containers that are available. So all Swing GUI will have at least one container. And because container, they are components, the container can also hold other containers. So containers are also components, and this enables Swing to define what is called as containment hierarchy at the top, which must be a top level container. So this is one representation of that. So here you can see that a panel, they are containers. So they can contain many other components. Similar to that, containers, they are components. And all J components are also containers. J component in Swing, you'll be saying everything. You will be having a letter J with everything. If you want to add a button, it would be J button. So that letter J would be there with everything. So all J components, they are also containers. And in Swing, everything is a container. So a J frame is a window, which is also a container. So we'll be seeing J frame. I'll be showing you programs related to J frame buttons and all. So Swing components, they are derived from J component class, and J component, it provides the functionality that is common to all components. And J component supports the pluggable look and feel. And J component inherits the AWT classes, that is you have container and component. From that, you will have the J component. And a Swing component, it is built on and compatible with an AWT component. And all of Swing's components, they are represented by classes defined within the package javax.swing. So these are the various class name for swing components. We'll not be doing programs related to everything, but we'll be seeing JLabel, JFrame, then JText area maybe. And I think in lab we have radio button related programs. So J button is there. So some of these we'll be seeing in our programs. And all component, I have already told that all component classes begin with the letter J. So a class for label would be J label. A class for button would be J button. A class for scroll bar, it would be J scroll bar. And there are two types of containers. The first would be the top level containers. You have the JFrame, JApplet, JWindow, JDialog. So these containers, they do not inherit J component, and they inherit AWT classes like you have seen component and container. So this was shown in that diagram. And unlike other swing components, which are lightweight, these top level containers, they are heavyweight. That means it uses resources of the operating system. And it makes the top level containers a special case in the swing component library. So the top level containers like these, they are heavyweight. And a top level container must be at the top of a containment hierarchy, and top level container does not contain within any other container. So I'll not be adding a JFrame into any other container, but I'll be using JFrame to add components. And every containment hierarchy must begin with a top level container. So the most commonly used for applications is the JFrame, and for applets we'll be using JApplet, but this is not part of a syllabus. We'll be only be seeing JFrames. And the second type of containers supported by Swing, they are lightweight containers. So they inherit J component. An example for lightweight container is JPanel, and it's a general purpose container. So lightweight containers, they are used to organize and manage groups of related components, because a lightweight container can be contained within another container. So your heavyweight containers cannot be, you cannot add a heavyweight container in any other container, but a lightweight container can be added in other containers. So you can use lightweight containers like JPanel to create subgroups of related controls that are contained within an outer container. So top level container defines a set of panes, and at the root of the hierarchy, you have something called as JRoot pane. It's a lightweight container whose purpose is to manage other panes. So it also helps to manage the optional menu bar. And the panes that consist the root pane are called the glass pane, the content pane, and the layered pane. So the glass pane, it is the top level pane, and it sits above and completely covers all other panes. And it is a transparent instance of JPanel. So glass pane enables you to manage mouse events that affect the entire container, or to point over any other component. So in most cases, you won't have to interact directly with the glass pane, but if you want to, it is there. And the layered pane, it is an instance of J-layered pane. And the layered pane allows components to be given a depth value. So depth value means in order to see the, say, a three-dimensional effect or something. So this value determines which component overlays another. So the layered pane, it allows you to specify a Z order for a component, and it is not something that you will usually need to do. So the layered pane holds the content pane and the optional menu bar. And although the glass pane and the layered panes are integral to the operation of the top level container and serve important purposes, much of what they provide occurs behind the scene. That is, a user need not directly interact with it. And the pane with which your application will interact most is called as the content pane. So this is the pane to which you will be adding the visual components. And when you add a component like a button to a top level container, you're actually adding it to the content pane. So the content pane, it's an opaque instance of JPanel itself. So this is actually the structure. You have the frame, you have the root pane, a layered pane, J menu bar, and the content pane. So we'll be adding components actually to this content pane. So you have some theory to learn as part of GUI programming. So anyway, Swing is a very large subsystem and it has many packages. So these are the packages used by Swing, and it is defined by Java C6. The main package that you'll be using in your program is javax.swing. And this package must be imported to any program that uses a Swing. So it has classes that implement the components like the buttons, labels, checkboxes, and all. So these are the various Swing packages. So we'll be importing javax.swing. So remember that when it is a Swing, it is not import.java, it is javax. So don't forget to add that x. So this is one sample. You can see that you have a JFrame. This prompt that I've added here, that is there in the diagram, it is the J label. This is nothing but a label. You have the text field where you will be able to add or type some text. You have the button, that is when you say you have added hi here, and when you click that button, say convert, here in the text area, hi will be displayed. That is the purpose of this text field and J button in this particular diagram. So JFrame, this we'll be using in all our programs. So it is a class of javax.swing package, and it is extended by java.awt.frame. So you can see that when it is AWT, you have Java, but when you want to use Swing, it should be JavaX. So it supports, it adds support for Java Foundation classes bar Swing component architecture. So it is a top level window with border and a title bar, and Frame has many constructors which can be used to customize it. So you can either create an object corresponding to the JFrame class, that is called as association, or you can just inherit the JFrame class. So that is the, you can extend it, that is by inheritance. So these are the two ways. Either you can create an object corresponding to a JFrame class, or you can just extend that JFrame class. So these are the various constructor. You can just create the frame that would be initially invisible. Okay. So you have to use that set visible in order to see that frame. So this is where you can add a title. So it would create initially invisible frame with a specified title. So we'll see one small program related to that. So here you can see that I have imported, I just need that JFrame. So here I have imported that. So here you can see that import javax.swing.jframe, and I've created a class. So again, I need to have my main. So I have used that JFrame object. So JFrame, I have given one name to that object. I want to give a title. That is why I have hi here. Now you know that this would create an invisible frame. Okay. So by default, the frame that would be created would be invisible. So I want to make it visible. So this is mandatory. So I have jframe dot set visible true. So this will make my frame visible. So when I do it, I might get something like this. So I just have to click that maximize button. So I'll be seeing, I hope you're able to see. Anyway, here I have a title to my frame, that is hi. So this is the similar program. So here you can see that import javax.swing.jframe. So here again, I have my main. I've created a frame, an invisible frame. It will be an invisible frame initially. So what I've done is I have want to give a title to my frame. So here you can see hi is here. Now I want to give a width and height. So here you can see that this would be the initially created frame. So I don't want that. I want to have a width or size for my frame. So I am specifying the width and the height. So I have added 300, 300. So my width is 300 and the height of that frame is 300. So 300, I hope you know that it is represented in pixels and all. So this is the size of my frame. So I want to have a 300 by 300 frame, and I want to make it visible. So because I have my set visible true, I'm able to see it. So if it is okay, please message in the chat. So, okay. So that is the first program. So here you can see that I need to have a set default close operation. Okay. So you have a close button here, right? So when you click that close button, what action should be performed? That is that set default close operation. So you can see that jframe dot exit on close, that would exit the application. The default is this, that is hide on close. When if you didn't add the set default close operation, this is the action that would be performed. That is hide on close. Hide on close means it would just hide that frame, but actually it would be running in the background. Dispose on close means dispose the frame object, but the application would be running. The JFrame dot do nothing on close means you just have to ignore whether the user is clicking that close button, or don't mind that, just ignore it. So that is do nothing on close. So here, these are the different actions. So I'll add that also to my program. I have one program related to that. I'll show it to you. So here, before going there, I have my J label. So J label means it is the simplest and easiest to use component because it does not accept user input. So if I want to just display, say, something, say, I want to display hi on my frame, I'll be using a J label. So it's the simplest and easiest to use component because it does not accept any user input, and it could just display information which can consist of text, an icon, or a combination of the two. And label created by the program consists of only text which is passed to its constructor. So these are the various labels, constructors that are available for J label. So this is what we'll be using most, that is J label string S. So I can create a label with a specified string. So this is string get text, set text and all that we'll be seeing later in our programs. Anyway, if you want to have horizontal alignment, you can use set horizontal alignment. You can get icon, that is a graphical image that a label displays by using icon get icon. And get horizontal alignment means it will return the alignment of the label's contents along the x-axis. So again, this is another program where I have the label also in my program. So I want two things. So I have imported only that, or I can simply write if I want to import everything related to this, similar to the previous cases, I can just write javax dot swing dot star. So here I have explicitly imported my JFrame and my JLabel. Here you can see that again in my main, what I've written is I have used an object corresponding to my JFrame, and I want to set that title to be high. So this is high again. And here I want to create a label that is called as hello swing. Okay. So remember that whenever you create a component, I have to add it to my container. So here my container is my frame itself. So what I have done, I have created an object corresponding to my J label. I want this to be my label, that is hello swing. Now I'm adding that component into my container. So here jframe.add and specifying label. Now what I have done is same like in the previous case. So I want to have a set size that is 300, 300. Again, my width of the frame is 300. height is again same, that is 300. I am making the component visible, that is jframe dot set visible true, so that my when I run it, my jframe would be visible. So see the program. If it is okay, please message in the chat. Yeah, it is the default location answer. I do not specify where it has to be printed, right? So we'll be seeing how it can be specified and all. What about others? So swing programs, you have to try it out because it is easy to understand. But I have seen students not doing programs related to swing in labs. So try to understand it properly, how these are implemented. So only Ansel is here. Ashwin, okay. So only Ashwin and Ansel are here. Joel. Okay. So you know that there is something called as the main thread, right? So in the previous program, actually the GUI part is also done by that same thread. So I don't want that to happen. I want to use a different thread for that. That is GUI. I want to make it done by event dispatching thread. So this is that. You can either use this it is there in the swing utilities class. So I can use either of these method, that is static void invoke later, I need to specify the runnable object, or static void invoke and wait runnable object. It throws interrupted exception and invocation target exception. So we'll not be using this, we'll be using this. So obj, it is a runnable object that will have its run method called by the event dispatching thread. So the difference between these is that the invoke later returns immediately, but invoke and wait would wait until obj.run returns. So you can use one of these methods to call a method that constructs the GUI for the swing application, or whenever you need to modify the state of GUI from code not executed by the event dispatching thread. So you will want to normally use invoke later, but when constructing the initial GUI for an applet, you have to use invoke and wait. But because we are not dealing with any programs related to applets, we'll be just using that static word invoke later. So this is how you have to write your programs. So here I have imported everything that is part of swing. So here I have created a constructor. So swing demo. So here again I have my frame object. I want to give it a title, a symbol swing application. So similar to the previous case, I have set the size. Now here you can see that width and height are different. I can do it. I can give it anything based on my screen resolution. So here you can see that it is 27500, and here you can see that I have also specified that set default close operation. So I want to that whenever the user clicks that close button, I want to perform exit on close operation. Then I have a label here. So label, I have created an object corresponding to that. So here you can see that is set to swing means powerful GUIs. So again, when you create a component, it has to be added to that frame. So I have used that add method. I have added that label there. So here again, you can see that the set visible has to be made to true so that the frame would be visible. Now here is the change that I have made. So here you can see that I want to use that event dispatching thread to implement my GUI part. So here swing utilities dot invoke later new runnable. Then within that, this is the thread, right? So I have my run method. So here I'm using new swing demo. So this would invoke my swing demo. So the same thing like in the previous case, I'll be having my here my width is 275. That is the frames width is 275, and the height is 100. And I've created one label there that is a swing. Swing means powerful GUIs. This title that is there is a symbol swing application shown as the title. So if you want to use even this is the better method. So if you want to use that is event dispatching thread for rendering your GUIs, you have to use this approach. So remember that you are closing your swing utilities here. You have to close this part, that is that method, right? So I have to close that there, and I have to put a semicolon. So that is the syntax, how you can use the event dispatching thread. So that GUI would be performed by event dispatching thread and not by the main thread. So this is the better method, better approach of writing GUI based programs. So see the program. If it is okay, please message in the chat. So why no response? The same part, but what I have modified is this thing. Is it okay? Still no response? So Ansel is okay. What about others? Only Ansel is here. So this part is because in the previous program, you can see that I didn't write that. So here GUI is also performed by my main thread. So I don't want that. I want to use another thread for doing it. That is my event dispatching thread. So because our programs are simple programs, you can make your main thread to do the same task, but it is not the actual approach that should be implemented. So still I don't see any response other than answer. So Ashwin is okay. Okay, Lydia. Iron. So I hope it is okay. So because today is Wednesday, do join for the booster class, but I want everyone to join today, where we can do some programs related to this GUI. So do come for the booster class. It is not a booster class in reality, so do come for that. Do join at 8 p.m. So that is for today. Okay, thank you. Because I don't have time to make you do programs in my regular classes. So okay, thank you. You may leave the class.